You know, for centuries, tracking diseases was this slow, painstaking process. I'm talking paper, pen, and a whole lot of legwork. But today, we're in the middle of a digital revolution that is completely rewriting the rules for epidemiology. So we're going to break down just how computing power is changing the game in the global fight against disease.
And this slide really says it all, doesn't it? I mean, look at this shift. We're moving from the column on the left, paper-based, manual, and because of that, often tragically slow, over to the right, real-time, automated, and get this, even predictive. This isn't just an upgrade, it's a whole new strategy. We're finally moving from just reacting to outbreaks to actually getting ahead of them.
So, what does this digital revolution actually look like on the ground? Well, the whole story really is this massive shift in thinking, from being reactive, waiting for a crisis to blow up, to having a truly proactive public health strategy.
And just think about the real-world impact here. Faster outbreak detection, that can be the difference between a small, local issue and a full-blown global pandemic. More accurate risk assessments? Well, that means we can send help to the exact communities that need it the most. This lets us create these incredibly targeted, effective interventions, and it sparks a level of global teamwork that would have sounded like science fiction just a generation ago.
Yeah, this quote from a digital health expert just nails it. Technology is the engine that's giving public health a brand new playbook, and it's one that's finally focused on anticipating what's next, not just reacting to what's already happened. So how in the world is all of this possible? What are the actual tools that are making this proactive approach a reality? Well, let's open up the digital toolkit of a modern epidemiologist. Okay, so right at the heart of this toolkit is statistical software. Now, take a look at this table. On one side, you've got these open source powerhouses, R and Python. Notice the cost? Free. That unlocks some incredible flexibility for building custom models from scratch. Then, on the other side, you have the big enterprise tools like SPSS and SAS, which are known for being super reliable and a bit more user-friendly. It's really that classic trade-off, Do you want the raw, flexible power of open source or the structured support of an enterprise system?
But data isn't just numbers on a page, right? It has a location. And that's where Geographic Information Systems, or GIS, come into play. GIS is all about answering the critical question of where. This tech lets scientists literally map out an outbreak as it's happening, see the hotspots light up on a map, and figure out why a disease is spreading in a specific place. It's absolutely crucial for planning where to send everything from mobile clinics to vaccination teams.
So knowing where is powerful. But you know what's even more powerful? Knowing when, as in right now. And that is the whole goal of real-time disease surveillance. It's like a race against the clock, trying to shrink the time between that first case and a global alert. Because in epidemiology, speed literally saves lives.
Okay, so let's follow the journey of a single piece of data. It all starts with collection, maybe from a health app on your phone or an electronic health record at a doctor's office. Step 2, that data is instantly reported to a central dashboard, something like an integrated disease surveillance program. Step 3, powerful algorithms start crunching millions of these data points, looking for anything unusual. And if they find something, that's step 4, an early warning system is triggered. Think about that. A single data point can launch a life-saving response.
And these streams of data come from all over the place. Of course, we pull from official electronic health records. But we also use this really clever method called syndromic surveillance. It sounds complicated, but the idea is actually pretty simple. You track symptoms indirectly. So, for example, a sudden spike in Google searches for fever and cough in a specific city could be the very first sign of an outbreak, maybe days before anyone even goes to a doctor. It's all about finding the patterns hidden in our everyday digital footprint.
Now, collecting all this information is incredibly powerful, no doubt about it. But it also opens up some really serious and important questions. And that brings us to the critical intersection of data, ethics, and equity.
Which really forces us to ask a fundamental question, doesn't it? With this absolute fire hose of sensitive health data flying around the globe, how do we use it responsibly and protect the very people we're trying to help?
At the end of the day, the entire system is built on a foundation of trust, and that means having ironclad privacy protections, things like HIPAA here in the US. It means being totally transparent about how data is used and getting clear consent. And, this is a big one, it means constantly checking our own tools for algorithmic bias, making sure the systems we build don't accidentally make existing health disparities even worse.
And that leads directly to this huge challenge, the digital divide. I mean, think about it.
If our best surveillance systems rely on smartphones and high-speed internet, what happens to communities that don't have reliable access? We risk creating these massive blind spots in our data, making the most vulnerable people invisible right when we need to see them the most.
So, while we are absolutely wrestling with these challenges, technology is not slowing down. Let's take a look over the horizon at what's coming next for the future of public health. And the potential here is just staggering. Artificial intelligence is moving beyond just tracking outbreaks to actually predicting them. The Internet of Things, think wearable health monitors, could give us a continuous real-time pulse on an entire population's health. Blockchain might offer a revolutionary way to share health data with total security and transparency. And when you power all of that with the insane speed of 5G, you could get an alert from a remote village to a global response center in the blink of an eye.
Which leaves us with this one final powerful thought. In this new era, you could argue that data can be the new vaccine, a way to protect our societies from disease threats before they even have a chance to take hold. But, just like with any vaccine, the biggest question remains, can we figure out how to distribute this powerful new tool equitably so that it actually protects everyone?